Let's have a closer look at vertex array objects and vertex array buffers. Vertex array objects and buffers are defined in the initialization function. Basically, all the initialization code can be put inside the init function. These include setting up the vertex array objects and vertex array buffer objects, clearing of the Windows background and other OpenGL parameters, setting up vertex and fragment shaders, which is reading in the shaders, compiling them, and linking them. Let's consider a few other issues. Vertex arrays. Vertices can have many attributes. They can have position, but they can also have color and texture coordinates. A vertex array can hold all of these data, not just the position of the vertices. If you look at the types declared in vec.hatch, for example, point 2, you can define 3 vertices, each of which can be two-dimensional. This is just an example of how you can define the position of vertices as two-dimensional positions. A bit of recap on vertex array objects. Basically, a vertex array can bundle all vertex data, including positions, colors, textures, and so on. To define a vertex array object, we have studied this before, that we need an identifier which is of type GL unsigned integer, and then we generate the vertex array using the glgen vertex arrays command, and finally we bind the vertex array. At this point we have a current vertex array but no contents. Using GL bind vertex array to switch between different VBOs, we don't need to worry about this if the scene that we want to render is simple. In all the lab exercises, we only have a single VBO, where the buffer of the VBO stores only one object and its color. However, if we have several objects to render, we can put the vertices of different objects into the same buffer. If we have 5 objects to render, then we have 5 vertex array objects. Each time we call the GL bind vertex array function to bind a vertex array object, the vertex array object becomes the current or active object, and the associated vertex buffer object would be affected. The vertex coordinates or color attributes stored in the buffer might need to be modified. This slide simply highlights the fact that if you are using a Mac, you need to append Apple at the end of the glgen vertex arrays command and the GL bind vertex array command. Unfortunately, some of OpenGL functions are not completely platform independent, and these are the smaller changes that you need to be careful of. Vertex buffer objects or VBOs allow us to transfer large amounts of data to the GPU. We need to create and bind the VBO in a similar way like the vertex array object, and then copy the vertices to the buffer. These are the set of commands that we use for doing so. This is how data in the current vertex array is sent to the GPU. If we have a points array and a colors array, then we need to specify a large buffer for the VBO, and we need to call the GL buffer subdata for each array. We need a larger buffer as it needs to hold both points and colors. So we start with GL buffer data, define an array buffer, pass on the size of the points, and we add on the size of the colors over here as well, because this is going to be the same color containing both the data, the point locations and the color values. Then we load the data separately using the GL buffer subdata command. Other arguments are similar to the single buffer case. First we load the points, and then we load the colors. Notice that the size is the same in both cases, but the size is given here. But we have an offset in the case of the colors, because in the buffer first we have all the points and then we have all the colors. If you were wondering before what the offset is for, or what is the use of the offset, this is an example of the use of the offset parameter in the function. We can also specify more than one buffer object. For example, 2 buffer objects. Here we have defined an array with the name buffer, which has two elements. And now notice that while passing the name buffer to it, we do not use the referencing and symbol over here. This is because buffer itself is now a pointer to a two-dimensional array. So we perform the binding and send the data of the first buffer to the GPU using these functions, GL bind buffer, and we give it the first buffer, and then we use GL buffer data to transfer the data associated with this buffer. And next we bind the second buffer, which is buffer 1 at index location 1, which is the second buffer, and then we transfer the data in that buffer, which is the colors, to GL buffer data. The points could be an array of vector 2, vector 3, or vector 4. Similarly, colors could be an array of vector 3 or vector 4. Reading, compiling, and linking of the shader programs is done inside the initialization function. Init shader is a function that would compile the two shader programs and would link them. We pass on the identifier of these shader programs to OpenGL using the GLUseProgram function. If there is an error inside our shader programs, our compilation would fail and we'll get an error at this line.